You know, in basically every single piece of tech you own, your phone, your car, you name it, there's this tiny, unsung hero working away. And today, we're going to pull back the curtain on the capacitor. It's this small component with a huge, and I mean absolutely critical impact on, well, everything.
Okay, so let me ask you something. What's the one thing that can power a camera's super bright flash, smooth out the sound in your speakers, and start a massive motor, all in like an instant? Seems impossible, right? Well, the answer to all of that, and a whole lot more, is the hero of our story today, the capacitor.
So how can one little component do so much? Well, to figure that out, we've got to look at how it stores energy. And what's really cool is that its method is super simple, and it's completely different from a regular battery.
Okay, so at its core, a capacitor is surprisingly simple. Seriously, all it is two metal plates that are really close together but separated by some kind of insulator. We call that a dielectric. Now, when you connect it to power, positive charge builds up on one plate and negative charge builds up on the other. This creates an electric field in the gap between them. And that field, that's where all the energy is stored. It's not a chemical thing, it's a physical thing.
All right, to really get a feel for this, let's step away from the electronics jargon for a sec. Think of it like a dam. Not for water, but a dam for electricity. This analogy is actually perfect for making the whole idea just click.
So, picture this. You've got a water pipe, but right in the middle, there's a flexible rubber sheet stretched across it. Now, when water, that's our current, starts flowing, it pushes on that rubber sheet and makes it stretch. The more it stretches, the more pressure builds up behind it. That's our voltage. And eventually, that sheet gets stretched so tight that it completely blocks any more water from getting through. That is exactly how a capacitor charges up and then stops the flow of direct current. Pretty neat, right?
So, and this is a really important point, a capacitor is not just a fast battery. They work in totally different ways. A battery, it stores energy using a chemical reaction, and it's designed to release that power slowly and steadily. But a capacitor, it stores energy physically in that electric field we talked about, and it's built to do one thing, dump all that energy almost instantly. It's the sprinter in the world of electronics, where a battery is the marathon runner.
You might think this is a modern invention, but this simple idea has a surprisingly long and, well, frankly, a shocking history. No pun intended. It all started way before modern electronics, with an invention that was both incredible and, honestly, a little terrifying.
So back in the 1740s, scientists invented something called the Leyden jar. It was basically a glass jar lined with metal foil, the very first capacitor. A Dutch physicist, Peter von Musschenbroek, was messing around with one and accidentally discharged it, through himself. The shock was so powerful that he later said he wouldn't take another one for the entire Kingdom of France. I mean, these guys had literally bottled lightning, and they were finding out just how powerful it was, the hard way.
And that shock was just the beginning. The evolution from there is just incredible. We started with those big, clunky glass jars. Then, fast forward to the 1870s, and we get rolled paper capacitors, which were compact enough to make the first telephone networks a reality. Then came the 1950s and the transistor era, which needed something way smaller and more reliable, and boom, we get tantalum capacitors. And just a few years later, in '57, supercapacitors were invented, which just opened up a whole new universe of possibilities for energy storage.
So yeah, that whole evolution has given us this huge, diverse family of capacitors. And they're not all created equal. It's kind of like a toolbox. You wouldn't use a wrench to hammer a nail, right? Well, engineers pick different capacitors for very specific jobs. And the main difference between them all boils down to that insulating material in the middle.
Right, that material between the plates, the dielectric. That's the real secret sauce here. You've got things like paper, which is kind of old school but still used. Then there's plastic film, which is great for stability. You see ceramic ones all the time in high-frequency stuff. But for really packing a punch in a small space, you have electrolytic capacitors, which use this super, super thin layer of metal oxide. Every single one of these materials gives you a different trade-off between size, how much it can store, and how well it performs.
So let's look at how an engineer actually chooses one. It's all about trade-offs. If you need just a ton of energy storage, say for a power supply, you're probably going to grab an electrolytic one, and you just accept that it has a shorter lifespan. But if you're building a radio circuit that deals with high frequencies, a tiny, cheap ceramic capacitor is perfect. And for something that needs to be rock solid and reliable, like in really nice audio gear, a film capacitor is the way to go, even though it's physically bigger. Okay, so why does any of this matter to you and me? Well, it all comes down to the capacitor's greatest trick. It has this kind of superpower. It behaves completely differently depending on the kind of electricity you feed it. And this is the real key to why it's in, well, everything. You can think of it as having a split personality. If you have direct current, or DC, that's electricity flowing in just one direction. The capacitor fills up with charge and then stops. It acts like an open switch, blocking the flow. But with alternating current, or AC, where the electricity is constantly flipping back and forth, the capacitor is always charging and discharging. And because of that, it basically lets the AC pass right through, almost like it's just a piece of wire.
And that dual nature is why these things are the unsung heroes in all our gadgets. You know the power adapter for your laptop? The electricity coming out of that is kind of choppy. A capacitor smooths it out to give your computer the clean, stable power it needs. In your stereo, it's a gatekeeper. It lets the AC audio signal get to your speakers, but blocks any DC that could fry them. And of course, it's the component that delivers that massive, instantaneous burst of energy for a camera flash or to get a motor spinning. It's the ultimate filter, gatekeeper, and sprinter all rolled into one.
So think about that journey. From a simple glass jar that gave a scientist the shock of his life, the capacitor has become this tiny, essential component that our entire digital world relies on. It literally couldn't exist without it. And now, as our tech demands more and more power, delivered faster and faster, it really makes you wonder, what's next for this brilliant, almost 300-year-old idea?